This is my solution to question number 5 for homework number 2. So the question reads, the customer flow at a grocery store can be viewed as a Poisson process, i.e. the probability of the number of customer arrivals in a certain amount of time, so from 0 to t, equals k. And then that is equal to this Poisson function of e to the power of negative lambda times t, and that multiplied by lambda t to the power of k over k factorial, where again, k is the number of customer arrivals in a certain time frame. So suppose the probability that in 2 minutes at least one customer arrives equals to 0.3. So we have parts 1 to 4, A to D as I numbered them. So the first part is to find lambda, and then we have basically different asks. So first, the probability that in 3 minutes no customer comes, the probability that in 10 minutes at least 2 customers come, and the probability that in 1 minute exactly 1 customer will arrive. So essentially, we first lay out what's given. So we were given that first we were given the function here. So again, e to the lambda t is equal to, sorry, I'm trying to focus this here. So e to the lambda t times lambda t to the power of k over k factorial is equal to the probability that a certain number of customers will arrive in a certain time frame. And so because we were given that the probability is 0.3 for at least one customer arriving after 2 minutes, then we can infer that 1 minus 0.3 is equal to the probability of no customers coming in 2 minutes. And that's equal to 0.7. And that's when k is equal to 0 and then t is equal to 2. So to find lambda, we have basically it's just a plug and chug. So we plug in all the values that we do have. So we have 0.7 is equal to e to the negative lambda times 2 for 2 minutes times lambda times, so here I didn't bother plugging any numbers in because here we have 0 customers, so k equals 0. So essentially this whole thing is just 1. And then here we end up with 0.7 is equal to e to the negative 2 lambda. To solve for lambda, we take the ln of both sides. We end up with ln 0.7 is equal to negative 2 lambda. And then lambda is essentially equal to negative the ln of 0.7 over 2. And that's going to be approximately, so ln of 0.7 is negative, and the negative and negative is a positive. And so essentially that's going to end up being approximately 0.178, which we'll see for the next few parts. So that's lambda, and that's going to be really helpful for the next parts of the question. So part B is we're supposed to find the probability of no customers arriving in 3 minutes. And again, this is way easier when we have lambda because now we have a new t, so t equals 3, and no customers arriving in 3 minutes, so k is still equal to 0. So essentially we have something that looks like this. The probability is equal to e to the power of negative lambda t, so t is 3, lambda, and then again, this is again going to be equal to 1. Sorry, just here. So this is equal to 1 because it's divided by the 0 factorial. So you have e to the negative 3, and this here is lambda, and that's going to be equal to e to the power of negative 0.535, which is about a probability of 0.586. So moving along to part C, where we're supposed to find the probability that in 10 minutes at least 2 customers arrives. So if we're looking at the probability, this one's a little bit more complicated because now we have, it's not just a probability that in 10 minutes 1 customer arrives. We're now looking at least 2, which means that either 0 customers could arrive or just 1 customer could arrive in the first 10 minutes. So that probability is going to be equal to 1 minus less than 2 customers arriving, and then that's equal to 1 minus probability of 1 in 10 minutes minus probability of 0 in 10 minutes. But when you kind of realize that, then you can break up the problem that way. And so you still have your k, which is 1 in this case, t is 10, and here k is 0, and t is 10. And so that's reflected here. So you still have the e to the negative lambda t will be the same in both cases, but in the case where k is equal to 0, again, this is just equal to 1. And you can factor out your e to the negative lambda t, so that you end up with 1 minus e to the negative lambda times 10 times 1 minus lambda times 10, and then plug in your lambda so that you have 1 minus e to the negative lambda times 10 times 1 plus 1.78, and then that ends up equaling 0.5312, approximately. That's rounded. And then the last part of the question is the probability of one customer arriving in 1 minute. And again, you have all the information you need. You have your lambda, and you have your k, which is equal to 1, and your t, which is equal to 1. So the equation ends up looking like e to the power of negative 0.178, which again was approximately lambda times lambda over 1 factorial, which is equal to 0.149.